This is a demonstration of Exact Rebar, the reinforcing steel and estimating software. In this example we are going to import a drawing from PDF and draw a slab with cranked members in both directions. So reverting to our PDF, here is the slab in plan and in elevation. So we will take a snapshot in PDF. And return to Exact Rebar and paste. So here is our slab. So now we will scale it. And that dimension is 6,000. So now we have scaled our slab, and we'll close that scaling. So now we will select the slab with Plan, New, Beam Slab Rectangle. Now Exact Rebar gives you the facility to correct the area. We know it's 5400 on both ways, so we'll just correct that. And the depth of the slab, returning to the PDF, is 450. So now we have our slab in plan, elevation, and in cross-section view. So now we will apply stirrups, and the size is a D20, and we'll take a long bar. The cover is 40. And so we will go auto offset and apply our offsets. We don't require these vertical ones, so for neatness we will just remove those. And spacebar is repeat last command. So now we can draw our crank stirrup between those points. Now there are many ways to do it, but we will elect to start drawing from here, then extend back. And we know that it's 900 before the crank down, so we will go back. So we will draw the stirrup by starting at this point. We know that that is 900. We will correct that to be 900. We will come down at 50 degrees. The distance along here has to be 3000, because looking at that distance is 1200, that is 5400, so 5400 less 2 times 1200 is 3000. So we will come along here 3000. We will go up at 50 degrees. Next, and to be consistent with the last one, we will draw and finish to there, and there is our crank stirrup. Now going back to the PDF, it extends back 600, so that would be 450 back at this side, and then a crank down. So let's address that. We will go to trim and extend. We'll trim at the start, and we'll add 450. And we will go trim, extend, and keep. Now we'll bend it down, and we'll bend it down at the start, and we'll bend it down by 90, and the length after the bend is automatically 5, so we'll go add bend, and we've got it the wrong way, so we'll reverse it, and then we'll keep it. So now that end is complete. Selecting the beam, we have the same thing. We'll go trim, extend, and this time we'll do it at the end by 450. And we will also add a bend, and the bend will be at the end. And we'll reverse that, keep. So there is our stirrup. Now we will select the stirrup. This length, for the first length is 50 mils, we will say the spacing is 0. Then for 5300, we'll say the spacing is 400. And there are our stirrups added. Now we will refer to the longitudinal. So we'll close the stirrups and draw the longitudinal members. So the longitudinal steel is the same at 400. So we will start by drawing the longitudinal. We will make the cover 0 so that it's easier to calculate later. The rebar name is again, it is D20 long, and the spacing is 400. And we will draw longitudinal. We will come below this so we have clarity. We will come in 50 mil. Then we'll proceed to the other end and we'll come back 50 mil, so we'll make that 5300, finish. So there's our longitudinal steel. Now we need to crank the steel, so we will select it and we will now insert a crank, and looking at the PDF, the crank starts in at 900 and then it cranks down at 50 degrees. So going back to the drawing, we will start the distance at 900, the angle is -50 and the offset is 450 minus 50, which is 350. So there is the crank shown. Now we also want to crank the other end, so we will now go to the end. So now we have our member shown in elevation cranked in the correct way. Now this member starts there and ends there, so the start of the member needs to be project back. Looking at the cross section again, the start of the member needs to project back by 550 and then it's bent down. So we will do that. We've still got the members selected. We will trim extend, we will trim at the start, and we will add 550. Keep. And now we will add a bend, and we'll add a bend at the start, and it's 90 degrees, and it's bending in the wrong direction, so we'll reverse it and we'll keep it. So now we're reverting to that member there comes out here to lap, so it needs to come out 300 plus a lap of 400, or half the lap is 800, so it's 300 plus 400, which means we need to extend it by 700. So returning to there, we go trim extend, this time it's the end, and we need to add 700. Trim and extend. Okay. So that is our longitudinal cranked members drawn. Now we have the lapping members. Returning to our PDF, there are this lapping bar here, and that bar is 1800 from there, so we will just simply draw a bar and then we will trim it back by 1800 less 5400 less 1800, which means 3600. So we will draw the bar and we will go draw longitudinal, and we will just draw directly below these. We'll just put them 100 below, and then we'll move across to here and make 5300. Draw and finish. Now we have drawn the lapping bars. We will select them. And now we need to trim the start back by 3600. So negative 3600. Trim extend, shown here. So we'll keep. Now we need to extend the end and come back to the PDF. We've now trimmed the bar back to here, but it starts here, so we need to add 300 plus 400, so we need to add 700. So at the end, we need to add 700. Trim extend. Keep. Now we have our bars complete. We will go close, and we'll go close. And here is our steel shown correctly in plan view. We'll now go to 3D, and we can go to color, and we'll show them as D20s, and we can rotate. Then we'll go to the quote screen. This shows the costing based on the price in the database. The bill of materials shows we need 306 linear meters. The drawing schedule shows the cranked bars. They're slightly different, they're scheduled differently. There's the straight bar, and the optimization report shows the most optimal layout to produce the minimum waste for these bars. That is a demonstration on importing a drawing from PDF and putting in cranked members into a slab.